Good afternoon to all. Myself Prakash Kumar Dehury, Department of Computer Science, and now in this lab period we have to find out we have to know the optimal page replacement algorithm. Means FIFO, LRU, and optimal page replacement algorithm. So these are the three optimal page replacement algorithm. It means it replaces the page or it replaces the data from one page to another page using C programming language. So these are the in this experiment these are the program for FIFO, LRU, and optimal page replacement algorithm. So FIFO means fast in, fast out. In the previous lab we know FCFS, fast come, fast out. It means fast in, fast out. So means like a tray or like bricks. With the last bricks should be out from the what the first bricks add, it should be removed fast. तो fast in fast means जो पहले आएगा वो पहले remove होगा. And LRU means least recently used, means कौन सा बहुत कम बार recently यूज हुआ है. And the last one is optimal page replacement algorithm. So the page replacement algorithm is the FIFO, fast in fast out algorithm. In fast out algorithm, replace the page which is inserted fast. Means जो page, it means which page inserted fast should be replaced fast. So for your comment, so the new page inserted into the frame is attached to the next serial number and replace the page with smallest serial number. Like which fast inserted should be removed fast. So this is a program. This is the string. This is following string, reference string 859695758687. The reference string is So this is the reference string. So we have to find out the replacement algorithm using FIFO. FIFO fast in, fast out. FIFO algorithm fast in, fast out. So for this we have to find out consider three frames. If in the question or in a semester exam there is no frame, so you have to take any frame. You have to take either frame 2, frame equals to 2, or frame equals to 4, or frame equals to 5. So here frame equals to 3. In this algorithm, the frame is assigned as 3. So first one is 8, then 5. Then 9. So fast in, fast out means 8 in the string 8. So fast in 8. Then again 5. So 8 and again insert 5. Then in the string is 9. So 8 5 is there. Again insert 9. Then the new string is 6. But in this frame there is no 6. So replace the string which is fast inserted. In previous the fast inserted is 8. So replace it. So the new string is 6, 5, 9. Again new string is 9. So 9 is already there. No need to replace it. It means the same thing 6, 5, 9. Again the new element is string is 5. So 5 is already there, so no need to replace it. So the new element, new string is inserted, that is 7. So in the previous string there is no 7 is there. So first you can first in first out. पहले first in which one is first inserted? 8 is first inserted. So हम क्या करेंगे? 8 को हम पहले डिलीट कर चुके हैं. तो next one is inserted is 5. So in the string we have to cut or we have to replace 5. So the new string is 6, 7 and 9 because after 8 5 is inserted, again after 5 9 is inserted and so on, because first come first serve, जो पहले आएगा वो पहले सर्व होगा, first come first serve. Again the new string is 5, but in this string 5 is not there, so we can cut 9 because after 5 9 is inserted. So the new string is 6, 7 and 9. Again the new one is 8, new element is 8 because in the previous string 8 is not there. Which one? After 9 6 is inserted, so remove 6. The new string is 8, 7, 9. Again the new one is 6. After 6 is 6, which one is inserted? Again 5 is inserted, so here in the 6 is not there. So again in the previous string 8, 7, 9 is there, but the new element 6 is inserted. 6 is inserted. So we have to cut again first string code together, first string was the 8, so we have to cut 8, 6, 7, 9. Again 8 is there. Again which one is replaced? 9 is replaced, 6, 8 and 9. Again 7 is there. So 9 is equal 6, 8 and 9. In this way we have to find out these things. These things will be elaborated. 8, again 5, 9, 6 is there. So no 6 is there. So replace 8 to 6. 9, no need to replace. 5 is there, no need to replace. 7 is there. So in the previous thing there is no 7. So replace which one? 5. So new element is 6, 7 and 9. Again 5, replace 9, 6, 7 and 5. Again 8, replace 6, 8, 7 and 5. Again 6, no, replace 7, 8, 6 and 5. Again 8, 8, 6, 5. No need to cut. 7. So replace 5, 8, 6 and 5. So here this right thing indicate that there is page fault, but the cross indicate that there is no page fault. So the number of page fault equals to 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 is your page fault and no page fault is 1, 2 and 3. So page fault. So page fault percentage equals to percentage that equals to number of page fault divided by number of access into 100. Number of page fault divided by number of access into 100. So the number of page fault equals to number of page fault. कितना हुआ यहाँ पर page fault? In the previous question the number of page fault equals to 9. So 9 number of access 12 into 100, that equals to 75%. So the page fault percentage is 75%. So in FIFO page insertion algorithm, one concept is there, that is Belladi anomaly. It means if the number of frames increases, the number of page fault also. In the number of frames increases, the number of page fault decreases. So sometimes in FIFO algorithm, when the number of frames increases, the number of page fault decreases. This unexpected result is called Belladi anomaly. In some cases number of page fault also increases. This thing is called melodic anomaly. Now the next one is optimal page replacement algorithm. Optimal page replacement algorithm replace a page which will not be used for the longest time in future, and it should be in forward direction. Replace a page which will not use for the longest time in future, and it will be forward direction. Consider the string 85969575868 There are 3 frames. So first enter is 8, again 5, again 9, again the new string is 6. So in forward direction we have to check which is not used for the longest period of time. Which one is the longest period of time? 8 is not used for the longest period of time. So replace 8. The new element is 6, 5 and 9. In this frame 6, 5, 9. The 6 is inserted by replacing 8. Again the new element is 9. So 9 is already there, so no need to replace. Again the next element is 5. 5 is there, no need to replace. Next the element is 7. So forward direction take which one is not used for the longest period of time. In forward direction 5, 8, 6, 8, 7, but 9 is not there, so replace 9 with 7. The new element is 6, 5 and 7. Again 5 is there, no need to replace. Again 8 in forward direction 6, 8, 7. Which one is not used? 5 is not used for the longest period of time. So replace 5. Again the add 6, 8, 7. Again 6, 8, 7. No need to replace. 8 no need to replace. 7 no need to replace. So the number of page fault is 1, 2, 3, 4, 5, 6. And the page fault percentage is number of page fault by number of access. Sorry, 6 by 12 into 100. That equals to 50%. So 50%. The same question if first it pass out, the page fault percentage is 75, but in case of page replacement algorithm, the page fault percentage is 50%. Again, LRU. The last one is least recently used algorithm. In this algorithm, what? Replace a page which has not used for the longest period of time in past, and you can take in backward direction of the string. In page replacement algorithm, in forward direction, but in LRU, it should be in backward direction. So same thing, same string is there. Frame is 3. First insert 8, again 5, again 9, again insert 6. So in backward, go in backward direction. Which one is not used for the longest period of time? 8. So replace 8 with 6. The new is 6, 5, 9. Again 9 is there. Again 5 is there. Again the new one is 7. So in backward direction, which one is not used for the longest period of time? 5. So replace 6, 7 and 9. Again 5. Again, this one is 5. 5 is there, so no need to replace. Again 8. 8 should be replaced. The longest 9 is the longest line, so 7, 5 and 8. Again 6. 6 is replaced by 7. 6, 5 and 8. 8 is there. 7. 7 replace 5 because 5 is the longest period of time. Replace 6, 7 and 8. So number of page fault equals to what? 7. So page fault equals to page fault percentage equals to 7 divided by 12 into 100. That equals to 66. 8 divided by 12, 66%. So this is all about the replacement algorithm. And all the program of programming